Hello, and welcome back to Summarize Science. Today, we're looking at a paper that solves a frustrating problem with AI image generators. Why do they often produce bad-looking images when you ask for a low resolution? The paper is called NoiseShift, Resolution-Aware Noise Recalibration for Better Low-Resolution Image Generation by researchers at Rice University. The core problem is illustrated perfectly on this page. AI image generators work by starting with pure noise and gradually refining it into an image over many steps. However, the researchers found that the same level of noise has a dramatically different effect depending on the image size. As you can see in these examples, the noise completely overwhelms the smaller images, destroying far more of the visual information compared to the high-resolution ones. This creates a mismatch. The AI model was trained on high-resolution data, so it doesn't know how to properly handle this level of perceptual corruption in a smaller image. The result is often visual garbage, like the distorted images of the truck you see at the top here. They end up with strange artifacts and incoherent structures. So, the researchers came up with a brilliant solution they call NoiseShift. The best part is that it is a training-free method, meaning you don't have to spend massive amounts of time and money retraining the entire AI model. Instead, it's a lightweight calibration that's done one time for each resolution. It works by adjusting the noise level information that's fed to the model at each step of the generation process. Essentially, it tricks the model by telling it a slightly different, more appropriate noise level that accounts for the smaller image size. This graph shows what's happening. The gray line is the default noise schedule, but the colored lines are the new, calibrated schedules for lower resolutions. You can see that for smaller images, the system consistently uses a higher conditioning noise level to compensate. And the results speak for themselves. In these tables, the researchers show quantitative improvements across several models, including Stable Diffusion 3 and 3.5. Looking at the FID score, where lower is better, we see significant drops in the numbers for lower resolutions, indicating a major improvement in image quality. For example, on one dataset, the quality for a 256 by 256 image improved by over 31%. The visual proof is even more compelling. Look at these before and after comparisons on faces and objects. On the left of each pair is the original output, and on the right is the output using NoiseShift. The generated images are much more stable, detailed, and free of the strange artifacts we saw before. So let's recap the key points. High-powered AI image models struggle to generate quality low-resolution images because the noise they are built on has a disproportionately negative effect at smaller sizes. The NoiseShift method provides a simple, training-free fix by recalibrating the noise information the model receives, tailored to the specific output resolution. This leads to significant and consistent improvements in the final image quality. This work makes these powerful AI tools more efficient, enabling faster and cheaper generation for things like mobile apps, game asset creation, and quick design previews. It's a clever solution that makes AI more practical for everyone.